So in this video, we're going to go to one version of back titrations. Now, they're a really hard question, which you might get asked, but please bear with it and we'll get it done. Okay, so it's a big, long question. It's about a sample of M that's reacted with excess acid, too much acid, which means we need to know how much the acid reacted with M and how much was left over. So the student added 100 centimetre cubed of HCl at 2.1 to the 6.9 grams of the M. That meant there was excess HCl left over, and then they reacted the excess HCl with sodium hydroxide. And it tells you they diluted it, they put it up to 250, and they took 25 out, blah, blah, blah. Okay, and it did this. Let's move that to the side. The titers for this were here. Okay, so we've got the titers. Notice one of the titers is outside of the 0.1, so we're going to get rid of that. And then we'll get a titer from the two that are remaining, okay, because they're concordant titers. Then, before we do this, we're going to write an overall equation for this reaction. It tells you in the question that M is going to react with HCl, forms hydrogen and a solution. So if that's M, it's going to form M chloride. Okay, it tells you it's in the +2, so you end up getting an equation just like this. Okay, 2 chlorines per one of the metal, and you get half equations, losing 2 electrons, gaining 2 electrons. So let's get rid of that, and let's go straight into the back titration. The back titration is going to be step by step. The first thing is we're given the concentration of sodium hydroxide, we're given a volume, so we can work out the number of moles. Okay, so the volume of the sodium hydroxide is down here. Okay, because that's the titer, so that's the sodium hydroxide, and this is the concentration. So we're going to times those two together, okay, and that will get you your number of moles of sodium hydroxide. Now, that is in a 1-to-1 ratio with HCl, so therefore that's the number of moles of HCl as well. Now, that was 25 taken out of 250, so we need to times by 10 to get it back up to the number of moles in 250. So we times by 10 there, which is great. Now let's make some space. And then we have to look at a different reaction. So I'm looking now, I know the number of moles of HCl that has been left behind, that hasn't been used. I know the total number of moles of HCl, okay, because I know from the start. So I can take the total number of moles from the number of moles that was used up, the number of moles that was left behind from the total number of moles. That will give you a number of moles that you've used up. So if I want to know the number of moles of HCl, that's 100 centimetres cubed of 2.1. That means there's 2.1 in every decimetre, which means that I've got a tenth of that. So 0.210 moles, okay? So that's where you get the 0.210 there, because it's a tenth, because 100 is a tenth of a litre. So then look at that, we take away the number of moles that we've left behind, which means we have a number of moles which we've used up. So that is the HCl that we've used up, and it's this HCl here. Then we divide by 2 to get the number of moles of M. That gets you a number of moles of M, so I now have a number of moles of M because I've used this ratio. And now I want to know the molecular mass of M. Now I've got a mass of M, so 6.9 up there. 6.9, okay, divided by the number of moles, because that's atomic mass or molecular mass equals mass over moles. Okay, so I take the moles that are there, divide them into the mass, and I get 112.4. If you look on the periodic table, 112.4 is cadmium. So you can tell what element this is. Now that is the standard way to do back titration. So if you go through the video and write out each step in general, and then you could even go onto ChatGPT and says, make me up a back titration question, please. And you can test yourself, okay? But I do intend on putting worksheets on each video so you can use those as well, okay? But using ChatGPT to test yourself is a wonderful use of that resource. Anyway, I hope this all makes sense. Good luck.